All right, CNT120 OSI model. We're starting at layer 7 and working our way down. So layer 7, application layer. All right, application describes the interface between two applications on separate computers. So, maybe my web browser on my computer to the web server on, or the web server application on the web server I'm trying to communicate with. So I'm talking about that connection, that interface. So we're actually talking about these applications that we looked at earlier in the chapter, the SMTP, the POP3, the HTTP, the HTTPS, those kind of applications. I don't need a network to use Microsoft Word, but I do need a network to use my browser or my email application. They're kind of useless without it. So we're talking about those applications, that communication piece that's happening on the back. So if I take a look here, I have some examples of that. Software applications like Firefox, Internet Explorer, Mozilla, Opera, Chrome all use HTTP in the background. So we're talking about these applications back here. My browser talking to the web server using HTTP. Those are the applications we're talking about. And that's why up here we have World Wide Web, email, FTP, that sort of thing. We're talking about those applications. My computer talking to the web server. So layer 6 now, presentation layer. Well, presentation layer is responsible for the formatting or compression or encryption of my data so that the other end can read it. So example, an email message can be encrypted by my end on the operating system so that it's encrypted across the communication creation channel until it gets to the email server. That piece of it would need to be handled here at the presentation layer. Well, we can also think of things like this. Let's think of email for a second. I can use, Thunderbird email application on my computer. You can use Outlook email application on yours, but we can still communicate. And the reason being, because we're both using email application that's going to send the email in a format like TXT or HTML. My email I send to you is going to be either formatted as a text file or an HTML file, probably an HTML file. And your application on your end is going to read that. Well, as I like to say, what computer can read an HTML file or a text file? Well, pretty much all of them can. So when I send my email, it's going to get formatted in a format like a text file or an HTML file. That way, on your end, when you open it, you can read it. That's the job of my presentation layer, to get this formatted in such a way that the receiving end understands it and can read it. That's the job of my presentation layer. Things also occur, things like JPEGs and those sorts of things also occur in such a format that the receiver can read them. Encryption also happens here. File compression also happens here. Things like MPEGs and my encryption, AES and triple DES. Those kind of things are happening at this layer, and they happen in such a format that the other end can actually read this when it gets there. That's the job of my presentation layer. Layer 5, session layer. This is one of the little harder ones to kind of comprehend, because up here at the application layer, I can get my head wrapped around that my browser is using HTTP and talking to a web server using HTTP. That's pretty easy. I can get my head wrapped around the fact that, when I send my email, it's formatted in such a way so yours can open and read it. Okay. Or it's compressed or encrypted in such a way that yours can decompress or decrypt it and read it. Okay, that makes sense. The session layer is a little tougher. Sometimes books try to argue that this needs to get combined with another layer. Whatever, it's here. The session layer is really about syncing and recovering message as data transfers occur. Okay, well, let's think for a second. Have you ever logged into, let's say, your bank, and you've done banking and you stepped away to, let the dog out or let the dog in or answer a question that your kid asked you or something like that, and you come back and your bank session goes, hey, you've been idle for a while, and it logs you out. I wonder what's going on. things like this are going on. It's watching this session, watching nothing has happened, and logging you out. You've also been somewhere where maybe it's been idle for a while and you say, oh, yes, I'm still here, and you click OK, and it keeps you logged in, maybe like D2L or something like. Yeah, this is the kind of thing that's going on here. So there's a layer watching your communication session and making sure it all occurs, and if need be, pick up where it left off or close it out. That's the job of our session layer. That's the job of our session layer. Okay? Moving on to layer 4. All right, now we're getting into some more layers that I can actually put my fingers on, if you will, or I can actually put my hand on. The transport layer, this is responsible for transporting data, upper layer application payloads, if you will, from one application to another. So moving the data from my web browser to the web server, or moving the web page from the web server back to my browser. The two main protocols functioning in this layer are TCP and UDP. And they both serve a function, be that they are different. Okay? We have TCP, Transmission Control Protocol. This one is there to make sure a connection is set up with the other end and make sure that everything gets sent and accounted for. If anything goes missing, it gets resent. So this protocol is a connection-oriented protocol. It's there to make sure it gets set up, everything gets sent, everything gets accounted for, and when it's done, it gets all closed down. This gets used on things like, let me go right here. This gets used on things like emails, FTP, web browsing, that sort of thing. TCP gets used on these kinds of things. A partial web page is kind of useless. A partial email is kind of useless. So those kind of applications are going to use TCP. I don't have a choice. I can't flip a switch and change it. These applications use TCP. That's just what they do. Well, let's look at TCP a little closer now. It's going to make a connection end-to-end. So before I even download that web page, my computer talks to the web server and says, hey, web server, you over there? Web server's like, yeah, I'm here. It's like, hey, I'd like to get your web page. It's like, okay, let's do this thing. And now we swap files back and forth. I ask for it, it sends them to me. I ask for it, it sends them to me. And if something goes missing, it goes, okay, I'll resend that to you. And then after, a couple back and forths of that, boom, I get the whole web page. This is that connection-oriented protocol. That's what TCP is doing. When an upper layer application needs reliability, TCP is going to get used. Unfortunately, there's added overhead because of all this checking. Because it sends some and it goes, did you get it? I'm like, yeah, I got it. Here's some more. Did you get it? Yeah, I got it. Here's some more. Did you get it? Yeah, I got it. So this is going to add overhead. The trade-off is it's going to make sure I got it all. It's going to make sure I got the whole web page. It's going to make sure I got the whole email. A partial web page is kind of useless. A partial email is kind of useless. So TCP is going to be there to make sure that all the pieces get there. It literally is going to number everything. It's going to count for it all and make sure it all gets there. Excuse me. Meanwhile, UDP is here for a different purpose. When I don't need to worry about all that double checking and getting it there, but I do need to worry about making sure that it gets there quickly and there's no delay, UDP gets used because UDP is connectionless. UDP kind of packages it up, kicks it out the door and says, good luck, my friend, I hope you get there. So it does that. It's in a lot quicker fashion. There is little to no delay. So UDP gets used in things like domain requests, IP requests, and voice and video. These are the ones you can kind of get your head wrapped around very quickly. When I need to send voice and video, I don't need all this overhead. I just need it to send. You know, here's that frame of data. Frame. Keep them moving. That way the video gets there and it does not, glitch and jitter around and, glitch out on your screen. So things that are time sensitive, UDP is going to get used. And that's where over here, things like, here's dynamic host configuration protocol. This is your IP request. DNS is going to use this as well as voice and video is going to use this. And again, this is not something I choose. It's not something I flip a switch. It's doing this for me. So transport layer is really about getting it there And it has two main methods to do it. This connection-oriented TCP way, making sure everything's accounted for and everything gets there, or the UDP connectionless way to just get it there quickly. Go, 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 go for my voice and video data. That is my transport layer. That's my transport layer, my TCP and my UDP. Now, at this layer, we actually start adding some information to the data we're sending in the form of what's called a header. And this header is there with special information so the other end knows how to process it. And this gets done in a process called encapsulation. This is the letter example. When I need to package up my letter, I'll take my stuff and put it in an envelope and seal it up, and I start putting information in the envelope so it gets there. That's what's going to happen with my data. It's going to get encapsulated with header information, with control information, so it can actually get to the other end. So we now need to break into and talk about encapsulation. So we're going to pause our layer talk for just a minute, and we're going to add an encapsulation here. So here's Mr. Brown's drawing. Here was my piece of web request, if you will, or the web data coming back from the server. It doesn't really matter at this point, but here's my web data, HTTP data. At layer 7, it's still just data. At layer 6, it might get formatted as an HTML file. At the session layer, it's there kind of watching this communication, make sure it's occurring, keeping an eye out for it. When it gets to layer 4, we actually have a TCP header added. Some additional information gets added to this to say, hey, when this gets to the other end, I need you to process it this way. I need you to know this is piece 1 of 100. I need you to know this is piece 9 of 100 or whatever it is. This header information gets added. In this case, with HTTP, it's going to be a TCP header. So that TCP header has that information of, hey, I'm piece 9 of 100 or 10 of 100, and please handle me this way. This is now getting added at layer 4, transport layer. And now it's no longer called data. We now actually call it a segment. We actually call this a segment now. Okay, there's my layer 4. So far we have data, application data, that was my HTTP request, if you will. Layer 6, it's getting formatted as an HTML file to go over to the web server. Layer 5 is a session saying, hey, I'm going to keep an eye out for you, make sure this session stays open. Layer 4 says, okay, I'm going to take and put a TCP header on so the other end knows how to process this, knows it's maybe piece 9 of 100 or 10 of 100, whatever it is. So now we have some control information on, so this can get put back together or reassembled, or if a piece goes missing, I know to request for it. So this TCP header now has some information in for control purposes for this data stream. All right. We'll come back in the next one for layer 3.